In this video tutorial, what we're going to do is we're going to explore how to tell if two ratios form a proportion and how to solve proportions. So the first thing we need to recognize is that all that a proportion is it is two ratios that are equal. And so what we're going to do is we're going to look at three different techniques for determining if in fact two ratios are equal. So to do that, we're going to first of all take a look at this example. 3 to 12 is equal to 6 to 24. So we're going to decide if those in fact form a proportion. The first way that we can do this is we can look for what I'm going to call the pattern between ratios. So if I look at the 12 and the 24, is there a pattern between those two numbers? And in fact, I can see that if I go from 12 to 24, I would need to multiply that by 2. And when we're talking about ratios and proportions, we're always looking for multiplying or dividing patterns, never adding and subtracting. And likewise, of course, then if I go backwards, if I go 24 to 12, that would be dividing by 2. And so let's see if that pattern holds on the top half of the ratio as well. If I go from 3 to 6, in fact, yep, there it is again, times by 2. Or if I wanted to work backwards and go from 6 to 3, I can see that I divide by 2. So there's a pattern that is between ratios that is equal for both the bottom part of the ratio and the top part of the ratio. The second pattern we can look for is the pattern within a ratio. And for this case, I'm going to look at the top number to the bottom number. And so if I do that, I can see that 6 to 24, there's a pattern of times 4. And likewise, if I wanted to work backwards, divide by 4. 24 divided by 4 is 6. So there's a pattern there. And I'm going to look for the same pattern in the other ratio. So to move from 3 to 12, I would multiply by 4. Or to move from 12 to 3, I would divide by 4. So I can see again by looking within the ratio, I have the same pattern in both halves. I have times by 4 and times by 4, or divide by 4, divide by 4. And just to be clear, I wouldn't need to go both directions. Just sometimes I might use a multiplying pattern, and sometimes it might be better to use a division pattern. The final technique is something that's called using cross products. And for this case, what I'm going to do is I'm going to look to see if the top number of one ratio multiplied by the bottom number of the other ratio should be equal to the top number of the other ratio multiplied by the bottom of the other. So to do this, I'm actually going to write this as an expression. So to do this, I'm actually going to write this as an equation. So 12 times 6, so 12 times 6 should be equal to 3 times 24 if this were in fact a proportion. So let's actually test those out. 12 times 6 is 72, and 3 times 24 is also 72. So since the two sides are equal, I know that yes, in fact, this is a proportion. 3 to 12 3 to 12 and 6 to 24 form a proportion. Let's try this on the other side here. In this case, I'm going to look at the same three sort of patterns to see if they exist. Now, first of all, if I look between ratios, I can see that to go from 9 to 18, I would multiply by 2, but to go from 7 to 21, I need to multiply by 3. So that is not a proportion. Right? The pattern between the bottom numbers is not equal to the pattern between the top numbers in the ratio. The second way is to look for a pattern within a ratio. And 21 to 18, I don't really see a good pattern here. I don't know what that is, so I'm not even gonna bother with it. The idea here is just do ones that you know how to do pretty quickly. And so I don't see an obvious pattern between 7 and 9, so I'm not even gonna worry about it. Finally, I'm gonna work with cross products, and cross products really can be the most useful one because even if you don't see a pattern between or within a ratio, you can always do cross products. So in this case I have 7 and 18, and I'm going to test to see if that is equal to 9 times 21. And so 7 times 18, that's 70 and 56, so 126. And 9 times 21 is 9 times 2 is 18, is 188. So clearly there, this is not a ratio. And really I should have seen that, because if I look at the ratio on the left, the bottom number is bigger than the top number, but the ratio on the right, the top number is bigger than the smaller number. So that should have been a dead giveaway that those actually weren't a proportion. In this section, what we're going to do is we're going to solve the proportion. So in this case here, I actually know that these are a proportion, and I can see that pretty clearly because I have equal signs here. So I know that these are supposed to be equal. So the first thing I'm going to do is I'm going to look for some of my easier patterns. I'm going to see, do I see a clear pattern between ratios or within ratios? And if I look within the ratio 5 to 9, once again, I don't see that very clearly. So that's I'm not going to work with that one. I don't know what it is. But if I look between ratios 9 to 63, I see a pretty clear pattern of multiplying by 7. 9 times 7 is 63. So I can use that same technique on the top part of my ratio, 5 times 7, and that tells me that n is going to be equal to 35. Now, it's possible that you didn't see that pattern. So in this case, we'll go back to cross products. Remember, cross products will always work. So in this case, I'm going to have 9 times n, or 9n, and that's going to be equal to 5 times 63. 5 times 63. So 5 times 63. And what I get here is I actually end up with getting an equation. 9n equals 5 times 63 is 315. And so this is just a one-step equation. I divide by 9, and n is equal 315 divided by 9 is in fact 35. So this is just another way to confirm that my missing value is actually 35. Let's look at the proportion on the right here. And once again, I'll start by looking for my obvious patterns. And between 15 and 20, I suspect there's going to be something there, but I don't really know what it is. Neither number is a factor or multiple of the other, so I'm not really sure what that pattern is, so I'll just leave it. And likewise, if I compare 9 and 15, they look like they both have 3 as a factor, but neither one is clearly a multiple or factor of the other, so I don't know what that one is either. So that takes me back to my cross products. So 15W is going to be equal to 9 times 20. 15W is equal to 180. And I'm going to divide both sides by 15. Divide by 15. W equals 12. So this is how I can use patterns between ratios, patterns within a ratio, or cross products to help me solve a proportion.